Good day everyone. So now we're gonna tackle general integration formulas in U substitution. We're gonna recall our last lecture, general power formula, which is W is to N du is equals to U n plus 1 over n plus 1, which is U is equals to any function note that n is not equal to -1. And the logarithmic function equals to integral du over u is equals to ln u plus c, and in the exponential function e raised to u du is equals to a u plus c. The other one is a u du is equals to a raised to u over ln g plus c. And now we're gonna use an example in techniques of integration using the U substitution. Our first example is, this is using the, by the way, this is using the power formula. Using U substitution. Using U substitution. Our first example is integral of x dx over x squared plus 4 is to 2 equals to. Now we're gonna find first here our u and our du. Our u is this equation. You can find our u in the parentheses or in the radical sign, but in this equation our u here is in the parentheses, so our u here is x squared plus 4, and the derivative of that is 2x dx. So we're gonna just answer this. This will become 1/2. So our equation will be balance integral of 2x dx over our u here, and copy the square, u squared is equals to, and the 1/2 integral of 2x dx here will change into du over u squared. Now equals to 1/2 u. Put this up so it become negative du, negative 2 du equals 1/2 times u -1 over -1 plus c, don't forget your c, equals to 1/2 negative 1/2 times 1 over u plus c equals. Now here in the final answer, we just gonna substitute our u in here, x squared plus 4, so it becomes negative 1/2 times 1 over x squared plus 4 plus c. And that is our final answer. Here in the example number 2, we have equation, we're gonna use example 3t dt over cube root of t squared plus 3. As I've mentioned before, you can find your u inside the parentheses or in the radical sign. So our u here is t squared plus 3, and the derivative of that is 2t dt, 3/2. So our equation will be balance 2t dt over t squared plus 3 1/3. Our 1/3 here is just the radical, just the fraction form of cube root, equals 3 over 2 integral of du real 1/3 equals 3/2 integral of u raised to negative 1/3 du equals 3/2 times, we're gonna use now here our exponential, the power formula, u, it will become u negative 2/3 over negative 2/3 plus c equals, we're just gonna multiply it so it become 9 over 4 u 2/3 plus c equals, now we're gonna put our u here, so it become 9 over 4, and we're just substitute our u here in t squared plus 3, t squared plus 3 raised to 2/3 plus c, and that is our final answer for example number 2. And here is our last example, number 3. And an example is e raised to negative x squared plus 2x dx u d. So what do you think will be our u here in the example? This is 2. Sorry for writing it small. Our u here will be negative x squared plus 2, and the derivative of that will be, what do you think? It will be negative 2x dx equals negative 1/2. Put the negative 1/2 here, so our equation will be balanced over integral of e raised to negative x squared plus 2 parentheses, and our du here negative 2x dx equals to negative 1/2 integral of e raised to u du equals negative 1/2 eu plus c. Now I'm gonna put RU again. This one was to negative x squared plus 2 plus c. And that's how you get your final answer. Good day everyone. So today we're gonna tackle the integration by parts. As you can recall, the definite integral, the upper limit, for example, our upper limit here is 1, lower limit is 0. Arctan x over 1 plus x squared dx. Our arctan x here is our u, that is our u, and the 1 plus x squared dx will be our du. So our u is arctan x, our du is dx over 1 plus x squared. In here, now we're gonna look for our upper limit and lower limit. U for upper limit and UL for our lower limit. Arctan 1, arctan 0 is equals to 0, and our arctan times 1 here, it will be pi over 4. Now we can answer this. Equals to 12 of pi over 4 0 u du equals to u squared over 2 pi over 4 0 equals 1/2 pi over 4 times 2 minus this minus 0 raised to 2. This will be 1 times pi squared over 16 equals pi squared equals to 2 times 16 will be 32. And that's our final answer. Here in the integral by parts, we have a lot of techniques that we're going to be used. First technique will be the u substitution. It's number 1. And number 2 will be the trigonometric transformation. Trigonometric transformation. Oops. And the third one will be the integration by parts. The fourth one will be the reduction formula. The fifth one will be the trigonometric substitution. And the last one is the rationalization. These 6 will be the techniques that we're gonna use. This will be helpful for finding the answer. Techniques of integration using by integral by parts. If you want to recall, this is gonna be d times uv equals to u du plus v du. We're just gonna change that, so become u dv equals to derivative of d uv minus v du equals u dv plus uv minus integral of u v du. And that is the final formula for integration by parts that we're gonna use. For example, sine x dx, RU here will be the sine x u. This is the du. U is x, du is dx equals the derivative of sine is x cosine x minus integral of negative cosine x dx equals negative x cosine x. Negative plus negative will become positive. Integral of cosine x dx. Our dv is sine x, v is negative cosine x, sorry, and the final answer here will be negative x cosine x plus sine x plus c. That is the final answer for this example. In here, for our example number 2, ln x dx. RU here will be the ln x, and the derivative of that will be dx over x equals uv minus v du equals to x ln x minus integral of x dx over x equals our dv will be the dx and the v is x. X ln x minus, and here we're gonna cancel this one to become integral of dx equals to x ln x minus x plus c. And that's the final answer. So, good day everyone, and today we're gonna tackle about the trigonometric substitution. There is 3 types of in the trigonometric substitution, and the first type is if the integral contains a squared plus x squared, then use x is equals to a tan theta, and The type 2 is if the integrand contains a squared minus x squared, then use x equals a sine theta, or x is equals to a cos theta. And then the type 3 is if the integrand contains x squared minus a squared, then use x is equals to a sec theta. First, I will give you an example in the type 1. Example for type 1. Let's say we have a given integral of 4x squared dx, and let our x be 2 tan theta, and dx is equals to 2 secant there equals integral of square root of 4 plus 4 tan, oh wait, this is 2 tan squared theta 2 times 2 secant equals 4 plus tan theta times 2 secant is to 2 theta d theta. Then we're gonna cancel this out to become secant theta. So we have 4 secant here 1 plus tan theta is equals to secant theta. U is equals to secant theta. U is equals to secant theta tan theta. dv is equals to secant raised to 2 theta dot theta, and v is equals to tan theta equals to 4 secant raised to 2 theta times secant theta dot theta equals secant raised to 3 theta do equals secant theta tan theta minus integral of secant theta tan squared theta d theta equals secant theta tan theta minus integral of secant theta parenthesis secant raised to 2 minus 1 u, and then equals secant theta tan theta minus integral of secant raised to 3 theta plus integral of secant theta d theta. Now we're just gonna transform this one to integral of secant raised to 3 theta do theta is equals to 1/2. 2 is here to 1/2 secant theta tan theta plus ln secant theta tan theta plus c, and then equals 4 1/2 secant tan theta plus ln secant theta plus tan theta plus c, then 2 secant theta tan theta plus 2 ln secant theta plus tan theta absolute value plus c equals 4 plus x is 2 x over 2 plus 2 ln positive value 4 plus x squared over 2 plus x over 2 absolute value plus c, and then we're just gonna let our x again, let our x be equals to 2 tan theta x over 2, and then oh sorry, you can see secant 4 plus x squared over 2, and we're just gonna draw here the triangle here in the x, this is 2, and here is our theta 4 plus x squared, and then for our final answer we have x over 2 square root of 4 plus x raised to squared plus 2 ln absolute value x plus square root of 4 plus x squared over 2 plus c, and this is our final answer for the example number 1. And for our type 2, we have an example of if the integrand contains a squared minus x squared, then use x a sine theta or a cosine theta. And for example number 2, we have integral of dy over square root of 4 minus 9y squared equals, let our x be, let our y be equals to 2 sine theta, and the dy is equals to 3 over 2 cosine theta d theta. And here, to transform this, we have 3y over 2 cosine theta, so it will become just this. R theta is equals to arc sine 3y over 2. There. Here, the 3 squared, 3 over 2 cosine theta over square root of 4 minus 4 sine squared do equals 2/3 over 2/3 cosine do equals to 1/3 to 1/3 theta. Let's see. We just cancel this, so we can have here the 1/3 integral of do. Now our final answer is 1/3 arc sine 3y to plus c. Well, the arc sine here is our theta. We just put the value of our theta here. So this is our final answer for the type 2 example. And for our example number 3, for type 3 is integral of the dx square root of 4e 2x minus 9. 2ex equals to 3 sec theta, 2ex dx equals to 3 secant tan theta do equals to 3 sec tan theta do over 4, we're gonna put here our 3 secant theta, and we're gonna cancel out, so dx is equals to tan theta do. And for here, this one, secant is equals to 2ex over 3, and our theta will be arc sine 2ex. And this example, we're just gonna transform this, so it becomes tan theta do over 9 secant theta minus 9 equals to integral of tan theta do 3 tan theta equals to 1/3. Just pull this out and then in the sign, so dO will remain inside, equals to 1/3 theta plus c. And our theta, I'm gonna use b here, 1/3 arcsecant to ax over 3 plus c. And that is our final answer. Thank you. So good day everyone. Today I will teach you in topic called partial fraction. So there are three cases in partial fraction. The first case is case 1. We have a distinct factor, which is n over x minus a times x minus b times x plus c, and then equals to a over x minus a plus b over x minus b plus c over x plus c. And there's a case 2, consists of repeated linear factors, and n over x squared times x minus 1 cube equals to a over x plus b over x squared plus c over x minus 1 plus d over x minus 1 squared plus c over x plus 1 cube. And then there's a case 3, quadratic factor, which is n over ax squared plus bx plus c to a times 2a plus b over ax squared plus bx plus c, and then plus b over ax squared plus bx plus c. So now I'm gonna give you an example for case 1. So I'm gonna give you an example. Integral of dx over x cubed plus 3x squared plus 2x equals to, I'm just gonna transform these two, dx, now put outside an x, so it becomes x squared plus 3x plus 2 equals integral of dx over x plus 1, then x plus 2. And then we're gonna use our distinct factor, integral of a over x plus b over x plus 1, and then plus c over x plus 2. The x plus 1 is here and the x plus 2 is here. So we're gonna use our CAM. A is equals to 1 over x plus 1 x plus 2. Our x here become equals 1/2 0. B 1 over x times x plus 2. Our x will be here 1, so become -1. And for our c, we have x1 over x times x plus 1 and our x here is 2 is equals to 1/2. So here gonna answer now will become integral of 1/2 over x plus negative 1 over x plus 1 plus 1/2 over x plus 2. The 1/2 is here, the negative 1 is here, and the plus 1/2 is here. So our final answer will be 1/2 ln x ln the value of x plus 1 plus 1/2 ln absolute value x plus 2 plus c. And that's is our final answer for case 1, example 1. And for case 1, now we're gonna have example for case 2. For case 2, we're gonna have integral of x dx over x plus 1 x plus 2 raised to 2 equals to, we're gonna use the method again just use here in the problem number 1. So we have x plus 1 x plus 2 is equals to a x plus 1 plus b x plus 2 plus c x plus 2 raised to 2. And now we're going to transform this into a x plus 1 plus b x plus 2 plus c x plus 2 raised to 2 dx equals, and our a here is equals to x over x plus 1, our x is 2, so 2. For b, we have dx, its derivative, right? X over x plus 1, so x here will become negative 2, and our final answer will be 1. So in c we have x plus 2 raised to 2 is equals to, our x will be here negative 1, and the final answer is negative 1. So in here we have integral of negative 1 x plus 1 plus 1 x plus 2 plus 2 x plus 2 dx. Now we have our final answer, which is ln absolute value x plus 1 plus ln x plus 2 minus 2 over x plus 2 plus c. That's our final answer for example number 2, case 2. Now we have here in our case 3. So we have an example of let's see, 6 dx over x cubed plus 2x squared plus 5x equals 6 dx over x, so reduce become x squared plus 2x plus 5 equals, gonna use here our use coefficient method. So we can 6 over x squared plus 2x plus 5 equals to a over x plus b 2x plus 2 over x squared plus 2x plus 5 plus c x squared plus 2x plus 5. Now here are x squared plus 2x plus 5. This will come here, comes from here, goes here, and goes here. So we have 6 equals to a x squared plus 2x plus 5 plus b, we have 2x squared plus 3x plus c x squared x is to 1 and x is 0. We have 0 is equals to a plus 2b, which will our a will become 6 over 5, and in our x raised to 1 we have 0 equals to 2a plus 2b plus c, which we have our b is equals to negative 3 is to over 5, and there's 6 here is equals to 5a, and our c should become negative 6 over 5. And for here, continue here, become x a over x plus b 2x plus 2 over x squared plus 2x plus 5 plus c over x squared plus 2x plus 5 dx equals. So now gonna substitute our value a, b, and c. So for a we have 6 over 5 over x minus 3 over 5 2x plus 2 over x squared plus 2x plus 5 minus 6 over 5 1 over x squared plus 1 raised to 2 plus x dx. We have integral of 6 over 5 over x minus 3 over 5 2x plus 2 x squared plus 2x plus 5 minus 6 over 5 so 1 plus x dx equals to 5 over x ln x minus 3 over 5 minus ln x squared plus 2x plus 5 minus 6 over 5 1/2. This is become arctan x plus 1 over 2 plus c, and that's our final answer for this case number 3. And that's all. Thank you. So, good day everyone. And today we're going to tackle about the multiple integral. So, we give you an example. Our first example is integral of upper limit pi squared, pi over 2 lower limit is 0. The other one is just the same, pi over 2, lower limit is 0, x cosine xy dy dx. So what we're gonna do here now is to solve for the inner part. So we have pi over 2, lower limit 0. The derivatives for cosine is sine xy, pi over 2, 0 dx. 0 sine pi x dx, because the lower limit is 0, so you have now to multiply, plus, we're gonna solve now, negative 2 pi cosine pi over 2x 0. Now negative 2 pi cosine times pi squared over 4 negative 1 is equals to 1.134. That's our final answer for the example number 1. So now we're gonna proceed to example number 2. We have here upper limit of 2 and lower limit of negative 2. The second integral is 4 and lower limit is x squared. 6x squared plus 2y dy dx. So what we're gonna do here, we're just gonna solve again for the inner part. 2 negative 2 6x squared y plus y squared dx equals to 2 negative 2 4 times 6 is 24, right? X squared plus 16, 4 times 4 16 minus 6x raised to 4 plus dx equals to, so now is 8x cubed plus 16x minus 7 over 5 x raised to 5th to negative 2 equals to 102.4. That's our final answer for our second example.